Okay guys, so let's continue looking at application of trigonometric ratios and see how this is going to help us. And this is my last video looking at some examples relating angles and sides. Alright, so there is this question which says from the top of the building 300 meters high, the angle of depression of a car is 52 degrees. Okay, so this is the triangle that they've given us. So it's like there is a car that is going down the slope, okay? And then the question says from the top of the building. So we need to understand these things before we do anything. So the angle of depression that this car is moving along is 52 degrees. So it means this angle here is 52 degrees, all right? So then the question says, calculate the horizontal distance from the car to the base of the building, the horizontal distance. So from our understanding of basic mathematics, the horizontal distance they are talking about is this one here. Because if you've done some coordinate geometry, you will know that the horizontal axis is the x-axis. So this is the distance that looks like that direction of the x-axis. Now, they want us to calculate this distance from here to there. And then they've given us that this car is moving with a depression of 52 degrees. Now, the question is, how does this help us find this distance C? So let me just say AC. In fact, let me just call this X, this distance here. Now, you need to know that if we draw a line that is parallel to the horizontal distance they want to find, which is X, this angle here initially should be 90 degrees, but out of the 90 degrees we've been given 52 degrees. All right, meaning we need to find what this angle inside here is, because we need to use angles inside the triangle, not outside the given polygon. So if you know that this should have been 90 degrees, then you've got 52 degrees. Then the angle inside the triangle with reference to that depression that we've got should be 38 degrees if you take away 52 from 90 degrees. All right. So now, having done this, it means now this question is easy for us to work with. All right. So what we need to do now is to look at the sides that we've got and the angle that we have. With reference to 38 degrees, you know that the side that they want us to find now would be the opposite side. All right, and then this side, which is 300 meters, how long the car is from the bottom of the whatever, if it's the hill or whatever that is 300 meters. Then this side here qualifies to be called the adjacent because it is next to the 38 degrees that we are dealing with. So it's like we've got the adjacent and then the opposite. We've just been looking at trigonometric ratios. So what trigonometric ratio of the three that we know deals with the opposite and the adjacent? You can see that that's the tangent because it's got opposite and adjacent. So it means now that we are going to say tan theta, which is the angle inside the triangle, should be opposite over the adjacent. Now the question is, of these three things, we should have the theta, one of the sides or the two sides to find theta. What do we have? Our theta in this case is the 38. So we're going to say tan 38 degrees would be equal to the opposite. We don't know because the opposite is the x. So we're just going to say x over the adjacent. The adjacent is the 300 meters that we've got. All right. So the question wants us to find this x here. All right, which is the horizontal distance from the car to the base of the building. How do we find x given this? So all we need to do now is to say this over 1 and then we cross multiply. This is just basic mathematics. So that means x is going to be equal to tan 38 degrees multiplying 300. All right. So if you do that nicely on your calculator and giving your answer to three significant figures, you would find that the x, which is the horizontal distance, would be equal to 234 meters. This is to three significant figures. I'm not going to go into details put in the decimal points and everything. So it means the horizontal distance now from the base, okay, from the height of whatever that is going to be equal to 234 meters to 3 significant figures. So this means that this distance from there to there is 234 meters to 3 significant figures. Okay guys, it is important that we understand these simple mathematical manipulations like this one where we have to cross multiply. Let's look at the second and last example on these trigonometric ratios and see how that is going to help us. Okay guys, so now let's look at this last example here. We've been given this right angle triangle, and then they're asking us to find the value of x. Now the thing is, we are still looking at right angle triangles, so we need to write our famous SOHCAHTOA, which is a very nice short valve as remembering what sides we've got. So those 3 trigonometric triangles. So I'm going to do this quickly, and it's two marks. You can see it's a very easy concept. So we've been given these 3 things here, and then we've got this angle here. So making reference to this angle, you can tell right away that the side they want us to find would be the opposite to the angle, and then the longest side which is given, which is always the hypotenuse, is 29 centimeters. So of the 3 trigonometric ratios, we need to pick one that deals with opposite and the hypotenuse. You can see opposite hypotenuse, which is the sine. So we know that sine theta would be equal to opposite dividing the hypotenuse. And then the next thing is to make our substitutions here. So theta in this case is 53.2. So we're going to say sine 53.2 equals to the opposite, which we don't know in this case, which is x, equals to the hypotenuse, which is equal to 29 centimeters. As we did in our previous example, we need to say over 1 here because we want to find x. So if we cross multiply, 1 times x gives us x equals 29 multiplying sine 53.2. All right, 53.2. So if we do that nicely on our calculator, you would find that to 3 significant figures, you are going to have a decimal number here. You are going to get 23.2 centimeters to 3 significant figures. This is the requirement by the Cambridge and the Zambian syllabus. So this means that the length, which is x, would be 23.2 centimeters. So guys, to just conclude on our trigonometric ratio, the right angle triangle that you'll be given will be missing 1. And our duty is to first figure out what sort of trigonometric ratio we are dealing with by looking at the given sides and then the angle that we've been given. And to do that, we need to make reference to the angle that we've been given. In this case, we were given this side here, meaning the side they were asking was opposite to the angle, which makes this the opposite, and then the hypotenuse. And then you look at the sides that you've got. Opposite hypotenuse is sine. Then you go ahead and look at the formula for the sine theta. So guys, thank you very much for taking part in my trigonometry videos. I'll continue looking at 9 right angle triangle in my next videos that will be coming, where I will start looking at 3-sided polygons that do not have the right angle in them, which we call 9 right angle triangle, and see how we can find their sides, how we can find the angles without using the Pythagoras and the SOHCAHTOA method, because these methods, they are limited. They just deal with right angled shapes. Now we want to look at 9 right angled triangles that do not have 90-degree angles in them. Thank you very much for your time, and please share and like my page and my YouTube channel, which is Math Antenna. Thank you very much, and watch out for the other videos.